What if I told you about a sound, a tiny chirp, really, that traveled for more than 1 billion years just to tell us a secret about the universe? Well, in this explainer, we're going to track down that sound and uncover the incredible story it has to tell, a story that proved one of the biggest ideas about how our universe actually works. Okay, so it all kicks off at this exact moment, September 14th, 2015. On what seemed like a totally normal Monday morning, a signal hit planet Earth. It was unbelievably quick, lasting for less than a quarter of a second, but it was about to change astronomy forever. And this is it. This little squiggle is what it all comes down to. This was the signal, and it was picked up at two different observatories, almost 2,000 miles apart. It started as a super low rumble, around 35 hertz, and then shot up to 250 hertz. Scientists nicknamed it a chirp, and it was literally the sound of spacetime itself, ringing like a bell.
So that was the big question, right? What in the entire universe could possibly be powerful enough to shake the very fabric of reality? The answer? Well, it was even more spectacular than anyone could have dreamed up. It was a binary black hole merger. For the very first time, we humans weren't looking at something happening out in space through a telescope. We were actually feeling the vibration of space-time itself. We had just witnessed this incredibly violent and totally invisible cosmic smash-up.
What you're seeing here is the final chaotic dance of two absolute monsters of the cosmos. They were circling each other in nearly the speed of light, literally twisting and warping the space and time around them. And even though this happened 1.4 times billion light years away, its echo still reached us. Just incredible.
And the scale of this thing is it's hard to wrap your head around. These weren't small objects. You had one black hole that was 36 times the mass of our sun. The other was 29 times our sun's mass. And they crashed together and make one single spinning black hole that clocked in at 62 solar masses.
Okay, but if you're doing the math in your head, you've probably already noticed something's off. 36 plus 29, that's 65, not 62. So where did that missing mass go? I mean, we're talking about the equivalent of 3 entire suns just vanishing. Well, the answer comes from the most famous equation in all of physics, E equals mc squared. That missing mass wasn't lost at all. It was converted, in a blink of an eye, into pure energy. But not energy as light or heat. It was energy in the form of these incredibly powerful gravitational waves. Let that just sink in for a second. For one tiny fraction of a second, this one event outshone the entire visible universe. It was the most powerful thing humanity had ever witnessed, since the Big Bang itself. Absolutely mind-blowing. Now, to really get why this discovery was such a monumental deal, we gotta rewind the clock. Let's go back about 100 years to where this whole crazy hunt began. So, back in 1916, Albert Einstein, as part of his groundbreaking theory of general relativity, predicted these ripples in spacetime. But his own math told him that they would be unbelievably tiny. So tiny, in fact, that Einstein himself was totally convinced we'd never, ever be able to build an instrument sensitive enough to actually detect them. And you know what? He was almost right. For decades, it was just an idea on paper. Then, in the 70s, astronomers Hulse and Taylor found the first indirect proof by watching two pulsars spiraling closer together, a discovery that actually won them a Nobel Prize. But a direct detection, actually feeling one of these waves wash over us, that remained the holy grail of physics for an entire century.
So how on earth did scientists finally build a machine so ridiculously sensitive that it proved the greatest scientific mind of the 20th century both right about the waves and wrong about our ability to find them?
So, say hello to the hero of our story, LIGO. It stands for the Laser Interferometer Gravitational Wave Observatory. It's this huge L-shaped machine with two arms that are each 4 kilometers or about 2.5 miles long. And there are two of them, one in Washington and one in Louisiana, working together. Now this is the part that is just almost impossible to believe. When that gravitational wave passed through Earth, it stretched one of LIGO's 4-kilometer-long arms and squeezed the other by 1,000th the width of a single proton. That is, without a doubt, one of the most precise measurements humanity has ever made.
So how does it listen? It's actually a really clever concept. You take a powerful laser and you split the beam in two. Each beam travels down one of the long arms, bounces off a super precise mirror, and comes back. Now, normally, they get back at the exact same time and cancel each other out perfectly. But if a gravitational wave passes through, it makes one arm a tiny bit longer and the other a tiny bit shorter. That means the laser beams get back just slightly out of sync. And that tiny, tiny difference, that's the signal. That's the chirp.
So we found them. A massive achievement, no doubt. But the real question is, so what? Why does this really matter? Well, the answer is that this wasn't just about finding something new. It was about gaining a whole new sense to experience the universe with.
Think about it like this. For all of human history, we've studied the universe by seeing it using light, visible light, radio waves, X-rays. But light gets blocked by stuff like gas and dust clouds. Gravitational waves are totally different. They aren't traveling through spacetime, they are ripples in spacetime itself. So they pass through everything, carrying perfectly clear information about the most violent and hidden events out there. So what this really all means is we have thrown open a brand new window on the universe. We finally confirmed the last major prediction of Einstein's theory, and we've kicked off this whole new field of gravitational wave astronomy. Now we can study dark events that give off no light, like black holes crashing into each other. And maybe, most exciting of all, these waves could one day let us listen all the way back to the Big Bang itself, to a time before the universe even had light. Humanity has spent thousands of years looking up at the stars, and now, for the very first time, we're learning how to listen to them. It really makes you wonder, what other cosmic secrets are out there just waiting for us to hear them?